Hello students, good morning. In the previous class, if you remember, and if you have gone through the previous class, followed that one, then you must be remembering that we discussed about the question answers of chapter 2, right? So we discussed about the question answers of chapter 2 over there, and with that I also declared that or state that the chapter 2 is over. And with that probably I have said, I told you that I will be doing some revision classes, and this is in the previous class also we did, along with the question answers, probably we did a quick recapitulation of chapter 2. But in this lecture, in this video, we will be doing an overall revision. Overall revision of what? Overall revision means a compilation. That means till date, whatever the things we have studied till date, we have done chapter 1, and till we have also done chapter 2. We discussed about the exercises of both the chapters, along with the detailed discussion of the chapter. Now in this lecture, or in this today, we will be discussing once again, we will just go back to whatever we have done till date, chapter 1 and chapter 2, everything, and we will just do a recapitulation, a revision. Okay, we will do a revision of whatever has been done till date. So now probably we will be doing this, so without wasting any more time, so let's get started then, because that will help you also in regarding the understanding the chapter and the topics more detail, more clearly. And still, if you're having doubts with any of the particular portion of the chapters or any topics which still not clear yet, it can be you can have a quick recapitulation of that. You can clear your concepts, or you can just write to me or other teachers there. All right, so let's start our today's topic, that is a quick journey through states of matter and physical and chemical changes. The first thing which you people face difficulties, or rather which I have seen during checking the papers, that is regarding definition. Many of you write definitions, but the problem is I have seen either the keywords are missing or the sentence construction is not proper. For that reason, if the sentence construction is not proper, then the meaning is getting changed, or else if the what should I say, if you're using your own set of what should I say, answers, then with those answers some writing difficulties are there, examples not there. So today, first thing, when we are discussing a recapitulation, a revision work, the first thing I'll discuss how to write a definition. The very simple thing of writing a definition is a complete statement given in your book. Your book is having a very complete, a clear definition is given. Many definitions I've seen, and probably if I'm not wrong, by this time you're having your book now. So by this time you can go through your books, the chapters. So a clear definition is given over there, but that is not complete. Along with the definition, an example is must. Always remember that whenever you're giving a definition, whenever you are writing a definition, you should write examples. That is very, very important. You should write examples. Okay, that makes a definition complete. Okay, let me give an example. All right, the first, for example, the question you were having, what is boiling point? or you may also get defined boiling point. So defined boiling point, what is boiling point, what do you understand by the term boiling point. So all these are basically questions related to one particular thing, that is definition of boiling point. What's the definition? So first, what you're going to do is write this word definition. Before that, you may write answer on the left hand side before the margin of your exam papers. After that, definition, give a dash, colon sign, whatever you feel like. Then the temperature at which a liquid gets converted into its gaseous state under a particular environmental pressure. Clear? That means over here the keywords are when a liquid gets converted into its gaseous state. You may also write, some of you may write that, or rather I've seen written, from the liquid state into its vapor state. Of course, vapor basically, to be very, very precise, writing the answer very precisely, vapor is not a state in general. Have you heard the name? When we started with the discussion of states of matter, over there, do you write vapor as a state of matter? Or do you write gases as a state of matter? Do you write molten state as a state of matter, or liquid as a state of matter? Definitely, we do write liquid as a state of matter. We write gases as a state of matter. We do not write molten as a state of matter, or gaseous vapor state. Vapor is a state of matter. We do not write that. So for that reason, precisely, to be very, very precise, rather perfectly applied words, scientifically correct, that is to write temperature at which a liquid gets converted into its gaseous state under a particular environmental pressure. We know that pressure is, do not miss this word, environmental pressure. You may also use surrounding pressure. So the temperature at which a liquid gets converted into its gaseous state under a particular environmental pressure is called its boiling point. We know that boiling point changes by the application of pressure. Boiling point changes by the application of pressure. So with a change, so for that reason, since boiling point is dependent on pressure, that is environmental or the surrounding pressure, for that reason, mentioning this word environmental pressure is very important, is very, very important. Alright? After this, what next? We will have to give an example. The boiling point of water is 100 degrees Celsius at STP. Where what is STP? We discussed that one previously also, standard temperature and pressure. So you may write the boiling point of water is 100 degrees C at standard temperature and pressure. Or you may also write 100 degrees Celsius, boiling point of water is 100 degrees Celsius at STP. Both are correct, no problem. Okay, but what I've done, I have used this word STP, and within the brackets I've given standard temperature and pressure. That is, I'm using STP, it's a short form, and I'm giving the full form of STP. So that what's my benefit? What's my advantage? My advantage is, if I can use this word STP if required in my future answers. In my future answers, I can use this word STP with a condition that it's already mentioned, because I've already stated that STP stands for standard temperature and pressure. And throughout the rest of my answers or any other answers, After that, declaration. If I have to use this word, I can use this short form. I don't have to use the long form, standard temperature and pressure. So there remains no confusion that yes, this is STP, this is the full form, or the declaration is there. So from all the sides, from all the directions, your answer is secured, protected. All right? Okay. Moving on to the next. The next is, this is also applicable for writing laws. Laws, scientific laws. For example, you have read about law of conservation of mass or law of conservation of matter. In your book, probably you may read this, both the terms, or you may come across law of conservation of matter, or you may come across law of conservation of mass in your book or any other books. Both are the same thing. It's just mass or matter. The law remains unchanged. Both laws are the same thing, matter or mass. Now, if you're using this term matter, so your law should start with matter. If you're using this term mass, your law should start with mass, or within the law, you should use this term mass, not any other word. I'm considering law of conservation of matter. Now, a very scientific way of, or rather a beautiful way of presenting this is to write this law or any other laws within inverted commas. Because whenever there's a law, that means it is this result, that's basically a result, and it has been applied to many situations, many cases where the results which came out, it's perfectly fine, it's already validated, and hence it's better to write in inverted commas. Okay, that's very, so we write first as statement of the law. Matter can neither be created nor it can be destroyed through any chemical reaction. Okay, it can only be transformed from one form to another form. So what's the law states? What the law states? The law states that matter can neither be created nor it can be destroyed. So I cannot create matter, I cannot destroy matter. That means I'm carrying out, now the question is, matter, if I hammer matter, so by hammering, by cutting, by chopping, all these methods are maximum. If I can rather compel any substance to undergo a chemical reaction, then also matter cannot be created nor it can be destroyed. So I cannot create matter, I cannot destroy matter. What I can maximum do is I can transform matter from one form to another form. I can transform. The same thing if I'm writing in terms of mass. Both are the same basically, matter or mass. The law of conservation of mass, where it states, just replace this word matter by mass. That mass can neither be created nor it can be destroyed through any chemical reaction. It can only be transformed from one form to another form. Alright? So you have to just replace this word matter by the term word mass. The rest remains the same. Along with this, as I said, example. That's very important. For example, when barium chloride, bracket BaCl2, symbolical, reacts with sodium sulfate, symbolical, Na2SO4, barium sulfate and sodium chloride, BaSO4 and NaCl, is formed. Now you can do two things. Either the way I've written barium chloride, within brackets BaCl2, the symbols are also mentioned over there. So when I will write the reaction, will not be important that I have to mention it separately, the name once again. That which one is barium chloride, which one is sodium sulfate. But if I'm not mentioning over there in the example, over there as I mentioned, then it's better to mention at the base or to write the names of the compounds at the bottom of the compound itself. Okay? At the bottom of the compound itself. Okay. So, what's the conclusion? The total mass of the reactants and total mass of the products are equal. That's the conclusion. Now you may ask that, sir, we have to write so much. No, you don't have to write so much. For example, define law of conservation of mass, 1 mark. So you will just write the definition, that's matter. Just write the statement. Law of conservation of mass or law of conservation of matter, just write the statement. Law of, okay? But if it carries 2 marks, that means, so what you will write first? If it carries 1 mark, only this much. So if it is carrying 1 mark, you will only write this much, the statement. And if it is carrying 2 marks, then along with that, you will write, what you will additionally you will write? You will just write the example. Okay? Just a moment. Okay. So, as I was saying that if it is a 1 mark, then you will just write this one. And if you're just having 2 marks, then you will go for the example. Okay? So 1 mark and 2 marks difference. Clear? Alright. Moving on to another question. How to write a reaction in the best manner. That means I will write a reaction and it will create a fantastic impression upon the examiners. Yes, the examiner, whoever will be checking, will be thinking that this student is just is having a beautiful concept regarding chemistry, regarding how to write a reaction in a best possible way. What's that? The first thing, reactions, we know that we generally write by using symbols. Reactions we generally write by using symbols, we know that. Now, the first thing, we will write a symbolical reaction. Clear? We will write, we are writing we will giving an example, or we are not only example, rather the question is write the reaction between these two substances. Or for example, in the previous case, in the previous case, just the law of conservation of mass over there. What is there is a reaction given in words as well as in symbols. But in chemistry, reactions we hardly prefer in words. In chemistry, reactions we hardly prefer in words. We always prefer reactions are always to be written in symbolical form. Okay? But the first thing, we will write in symbols. The what next step? The reaction, we will check. The reaction needs to be balanced. The reaction needs to be balanced. Okay? You may tell me, so the previous one, the reaction is, and if you notice, there is a mistake in that's intentional. That's intentional. the reaction in the law of conservation of mass is not balanced. That was basically, it's given for you that whether you can identify or not, and probably yes, you may have identified that in the previous slide I've shown you, the reaction with barium chloride and sodium sulfate, the reaction is not balanced. It will be 2 NaCl, 2 just prior to NaCl, just write it down, number 2. What's the next? Name the reactants on the products. That makes the reaction more informative. Make the reaction more informative. So how to write the names? You can write in 2 ways, as I said. Either you write the reaction in words, or there we mention the symbols, or you write the symbolical reaction, and then under the reactants and the products, you just write the name of individual compounds or individual reactants. That's all. Another thing is there, which can make the reaction more informative, more right in the best possible way. That is, if you can mention the state of the reactants and the products. If you can mention the state, once again, solid state, liquid state, gaseous state. If you can mention this state of the reactants and the products, now that makes the reaction, these 4 steps are the things which we need to follow up in order to maintain, or rather the best possible way to write a reaction. Okay? Sorry, this another point has been repeated. So the first 4 points only. Okay? Moving to the next. Now, another thing I have seen, how to write differences between anything. What's the difference, or how to write differences between two things? Anything. I'm not specifying any particular thing, any topic, but it's a general difference writing. How can we write difference? I have seen many students give up, rather submit, or rather writing. Either they write the entire story of the topic as the difference between the 2 topics, or they only give, for example, examples. What's the thing? Do we need to write the theory? Theory means in a short form which explains the matter, or do we have to give examples only examples are sufficient to give theory, or examples do we have to give as differences? So only theory or only examples? What do you think? What do you think? Confused, right? Okay, so let's try it out to remove the confusion. The first is tabular form. The point number 1, as you can see, tabular form. Always write differences in tabular form, in tables. The second, theory will be first. Theory means explanation of the terminology. That means definition. Whatever thing, try to write a brief definition if a definition is possible. Of course, if a definition is feasible for the topics, then please do write the definition first. Alright? Please do write the definition first. Now, if the differences are after that, now whatever the terms or the topics are given for writing the difference, if you see that no such proper definition are possible, or no such definitions really exist, then if the differences, then check for the criteria. Are there any criteria or any features mentioned in the question paper, or that on this particular point I have to write the difference, or on this particular point I have to write bring out the difference? Either the points are stated in your book separately, or the points, you have to find it out. Either the points are written or mentioned separately in your book, or those points are not separately mentioned, but within the explanation or the definition, those points are clearly mentioned. So bring out those points, and based on that, then write the definition, or then write the difference between the two topics or the two terms given for writing the definition. The next is, examples are not to be considered as differences. Of course not. Now, if your examples are not to be considered as differences, if the question is, suppose you are thinking about the difference between two animals, or for example, let's consider two or other animals and birds. So what you will write? You will write the difference is tiger and crow or eagle. You write these. Not at all accepted. It is not at all accepted. Cows or tigers and birds, or rather eagles and crows, these are not differences. The examples cannot be difference. So what's the difference then? You have to go for the features of the individual topics, individual categories, features. Those are the differences. Now, if you see that now examples can also be considered as differences. The only criteria is, if you see there are 3 marks given, and the number of differences feasible are 2. That means marks more, difference is only 2. Then you give example as one of the difference. Marks 3, difference 2, then you give examples as one of the, then examples will be considered as one of the difference. Clear? Okay. Now let's do some real life applications, some brain tweezers, right? It will be fun now. Okay, some brain tweezers. Can you see what you observe over here? You can see some candles are burning, and there is a what type of change do you observe? The first, visibly you can see there is a size change, right or wrong. There is a size change. So candle is burning, and you can gradually see there is a decrease, gradual decrease, right? Now, what type of change do you observe? It's a physical change. Is it a chemical change? Is it a physical plus reversible change? Is this a chemical plus reversible change combined? Is it a physical plus irreversible change? Is this a chemical plus irreversible change? Now, what do you think? Does it stops over here, the combination? No. Because if you see your book, it's having so many numerous changes. Natural change, artificial change, desired change, undesirable change, fast change, slow change, periodic change, non-periodic change, physical change, chemical change, reversible change, irreversible change. If I have to mention this one precisely means exactly to the point that what exactly is happening. What type of change do you observe? I have just mentioned 6 changes, but if I go into the finest and the minute detail to be included over here in one line, I will consider then what change I will write. I can mix up all the changes. So what exactly the change is taking place over here. Now you will write this as one of your home assignment, this question. Okay. Now over here, as many options are given over here. This is basically both. One is physical plus irreversible change, and rather not physical plus irreversible change, physical plus reversible change, and chemical plus irreversible change. There are two perspectives. One is candle is made up of wax, it's melting. So it's physical plus reversible change. And since the size is going down, so it's chemical plus irreversible change. So two changes involved, physical plus reversible change and chemical plus irreversible change. But these two does not exactly that in one change, that in one line you will write, and all the things will be cleared exactly what change is taking place over here. I want that one change, one line. Okay? That's your one of the assignments. The next we are having related to this, one observation, as I said in discussing that changing solid wax changing to molten wax. Can you point out any difference existing between these two waxes? What do you say? Can you figure it out? Any difference between these two waxes? Not boxes, it's waxes. Can you figure it out? Yes. Very correctly. The first one is regarding in terms of state. One is solid, one is liquid. So in terms of, it's one of the feature then. So one difference in terms of state, one is solid, another one is liquid. The next is particles are randomly moving in molten wax. Of course, Brownian motion is high in molten wax in comparison to solid wax. The third, intermolecular force of attraction is less in molten wax. Intermolecular force of attraction is less in molten wax and is more in highest in solid wax. Okay, so I've stated over here 3 points, 3 differences, but many other differences also exist. So this will be another one of your assignment, that you will be writing 6 points, and that you will get a separate assignment list. Over there, this question has been given. You have to mention 6 points, where you will make 3 columns. One, you will state the feature or the features. That means under which heading, on which category you are differentiating solid wax and liquid wax. Clear? The next, you can see 2 pictures now. One interestingly shows the water cycle, and another one is a symbol. It's of Indian, as you can see. It's relevant, safe, reliable, convenient, but Indian. You may ask us, so suddenly what happened? One side you are showing water cycle, and on parallelly you are showing Indian. It's becoming fun now. I'm serious. Now this is pretty interesting and it will be fun. So let's check it out. Can you spot precisely the difference between these 2 pictures? Now, please don't tell me, so there's a clouds and mountains and river and oceans over there and nothing over there. And over there I can see some Indian written in red or orange color over there, not written, and over here in the water cycle it's not written. These are not the difference. Precisely the difference. Think about it. That how these 2 are different, on what context these 2 can be different. Yes, you got it correctly. You are thinking in a pride. Think of the relation. What is Indian basically? How Indian, what Indian does? Supply gas cylinders, right? What type of gas cylinders? LPG. LPG, if you just go through a recapitulation, LPG is an example related to which particular category or which particular topics discussed in or we have discussed. That is, of course, liquefaction. And what's the opposite of liquefaction? What is over here? What you can figure it out? It's written over there clearly. Exactly, condensation. So you have to write the difference between condensation and liquefaction in a tabular form. That's also one of your homework. Difference between condensation and liquefaction. So I hope by this time it's clear how water cycle and indane can be related. So if you can go back just to think about it clearly, deeply. Clear? Indian LPG cylinders, right? Indian LPG cylinders, and so LPG cylinders are liquefied petroleum gas. And what about this? So what that means? Liquefaction, an example. Another example of liquefaction. And opposite of liquefaction is condensation. So just to write the difference between condensation and liquefaction. What's liquefaction, you know? Converting gases into liquids and by the application of pressure. And condensation is normal. Condensation is normal. What? Yes, condensation is normal conversion of gases into liquids without the application of pressure. So that's all for today's revision class, and maybe possible that I can do another revision class, one more revision class with you based on this chapter and application in real life application regarding these chapters. Okay, so this is the homework, and the homework list, and as a homework as an assignment list is given separately. You may find it out in your classroom. So that's all. Thank you. Okay, and stay home.